All right, so here's a continuation of class 14. We're going to do the slider crank now, look through the lecture portion of this, where we're just going to set the thing up. In a previous video, we walked through the and when we did the crank slider, we did the vector loop here, and we came up with the solution for this was going to be after we went ahead and put the Euler identity in, we found a omega 2 j cosine of theta 2 minus a theta 2 sine of theta 2 minus b omega 3 j cosine of theta 3 plus b omega 3 sine of theta 3 minus d dot equal to 0. And then we had the real and the imaginary of minus a omega 2 sine of theta 2 plus b omega 3 sine of theta 3 minus d dot equal to 0. If we happen to know that d dot, right, then we could, okay, so in this case, right, so maybe I ought to back up and redefine what a slider crank is. A slider crank is we slide it and then we make this thing crank, right? So even though it's the same drawing, it's the input and the output are something different. So what we would be inputting into this would be d dot. And then what we're going to want to try to find is what omega 2 is going to be, and omega 3. Those are the unknowns. So that's the this is the imaginary, and then if we did the real, no, this is the real, right? Because it's the sines. If we did the imaginary, it'd be a omega 2 j cosine theta 2, and then simply minus b omega 3 cosine of theta 3 equal to 0. I think we have to do a little bit more manipulation here, and maybe use, yes, and we need to use a trig identity in order to get this algebra worked out. But what we're left with when we're done with it is that omega 3 is equal to a omega 2 cosine of theta 2 divided by b times cosine of theta 3, right? But in order to get that, then we need to know what omega 2 is, right? So that was we were able to get that from here. So with some manipulation, we're able to find that d dot, oh no, excuse me, take that again. D dot is something that we know. In order to find what omega 2 is going to be, we're going to take d dot times the cosine of theta divided by a times the cosine of theta 2 sine of theta 3 minus, gotta get this right, sine of theta 2 times the cosine of theta 3. So you can see that they got reversed right there. So that's what we would get if we were looking for it in a crank slider. A slider crank. I said it wrong again. And they actually, in another book, have this, the slider crank listed right there. And so that you could see, here's how, yeah, so there's the D. This is, I think I would call this the crank slider, but they called it the slider crank in Nitschke's. We will we're just going to go ahead and use these equations, but we want to know how they're arranged. You do want to be careful. This one's theta 3 is going to be different from our theta 3. Our theta 3 gets defined clockwise from horizontal, whereas this theta 3 is counterclockwise because it's an interior angle. And that's it. It's a short video, but I went into tablet mode hoping that would work better. Oh, now I don't see it. Oh, how do you get out of this movie now? Maybe we come to here. No. What do you do? What do you do? How do you stop this movie? I was recording this. Oh, there you go. Oh, there you go. Okay.